about quantum relativity, which is a little bit outside the field of this conference, but it's useful to people who are working in the fields that you're all working in. It concerns relativity, which was a subject started by Albert Einstein in 1905, and pretty well he came to a sort of rather unsatisfactory conclusion in 1915 with a general theory of gravity, which most people don't seem to understand, but it's not difficult to understand if you persevere with it. And quantum relativity leads us to the general unified theory of universal gravity. What Albert Einstein gave us didn't really make a lot of sense, but his equations are perfectly correct for his general theory. But understanding them requires the general unified theory, and then that's the completion of space-time for physics. Also, some people call it GUT, but that's just some say the G stands for grand, but I don't like that because it's nothing grand about it. It's just a general unified theory of universal gravity or universal space-time. Now, to understand this unified theory, you need what I call the unified theory of finite natural numbers. In other words, the numbers that we've been taught by mathematicians for the last 2,000 years basically don't work anymore. We need better number theory than what they base on. They base their number theory on an abstract, I would say later, one having examined it, deranged set theory of numbers. And what we need is a unified theory of natural numbers, or what I call finite natural number theory. And this was first published by myself on the 21st of June, 2022. I was a bit embarrassed to publish it because I thought it was so obvious that, why do I even need to teach anyone to suck eggs? But my son, who's a mathematics professor, told me that it's not obvious at all, and that he's absolutely sticking to his abstract set theory of numbers. But once you become familiar with the unified theory of finite natural numbers, I don't think you'd really want to go back to what the mathematicians teach our children at university. This is a diagram showing the unified theory of finite natural numbers, and all that's shown on this diagram is unity, one, and its polarities. And they talk about this here. This is +1 for them. I'm saying that's a clumsy shorthand. And they say this number here is -1, and that's also a clumsy shorthand. But these numbers arise from changing the definitions of things. Now, this word here, direct, inverse, and lateral here, these words come from a paper written by Carl Friedrich Gauss in 1831. So this is not exactly the latest thing. But Gauss never completed this, and the reason he couldn't complete it was that Gauss was stuck with the radian unit of rotation or rotational angle. If you get rid of the radians are still useful in geometry and trigonometry, of course, but this is number theory, and the radian is not a useful figure in number theory. We need the quadrant. So there are 4 quadrants in a completed rotation. Let's put some practical bias or a practical explanation of this diagram in terms of, let's say, am I talking about the money that I owe my banker or that my banker owes me? So if I owe the banker money, let's say that's the direction. Yeah. So it's a debt of me that goes to the banker. But if it's actually that I've got a positive balance at the banker owes me, then we need to make a rotation. It's either me to the banker or the banker to me. And the difference between those two is a rotation. And if you understand that rotation to be 2 quadrants of rotation, then you get to this diagram. I here does no longer mean the square root of -1. That's wrong. I means times a rotation of. And now what they call 1 becomes 1 times the rotation of nothing. And what they call -1 is what we must call inverse 1, and that's a rotation of, that's 1 times the rotation of 2 quadrants. And that rotation can be left or it can be right, but it doesn't make any difference. You still get to the same value. Now, the advantage of this kind of thinking is that this is 1 times the rotation of 2 quadrants, left quadrants, or 2 right quadrants of rotation. And then we can understand the square root of -1 as being a backwards rotation from 2 rotations into the inverse. And that gives us the right lateral and the left lateral. The left lateral is the conventional direction of rotation, but Euler said that e to the I pi equals -1. Well, for a start, it's e to the 0 plus I pi that equals -1. And what's pi got to do with it? It's just 2 quadrants. And if you're interested in taking this further, then there's a complete walkthrough all the way from exponential arithmetic into this finite theory on my website. If I go back, I can just point out where you can see that. Here, gnqr.co.uk, which stands for Gauss-Newton quantum relativity. And you can't even read about that subject until you've gone through a treatise on finite natural number theory. So where I apply this new arithmetic, or this unified arithmetic, is only in relativity, but it's always helped me in electrical engineering and quantum physics as well. This is a diagram showing the whole universe, believe it or not, but rather simplified, of course. The white space above my purple dot and dash line represents what I call the quantum domain. That's where everything really happens. And it's also could be described as Maxwell's 377 ohm superconductive waveguide of free space, everything lying above the PEC line. And that quantum domain is an infinite singularity with respect to everything in space and everything in time. We actually exist upon the purple dot and dash line, which is a one-dimensional presentation of space now. So forget about time. It's just the instant of now, always, all the time. And the units of those spatial separations are in seconds. And that might seem a bit weird to people, but if you look at the CIPM's definition of spatial separation, it is the light time of flight. So instead of 1/c seconds, just let's say 3.335 nanoseconds. That's the definition of a meter. And that's independent of gravity. It's always true. Now, what has happened in the past? Well, where is the history? Where's the history of this event horizon? That's time now. What happened to times past? Well, you can think of the position in space of times past as being an imaginary historic depth, backwards from that line, away from the quantum domain, back towards what I'll call the gravitational domain, which is another infinite. There are 2 infinite singularities in the universe, and what's spread out between the space and time that we experience is a 4-dimensional mirage, which is created by the quantum domain, using the gravitational domain to give us this shape of matter and space and time. But time doesn't really happen. What happens is that history retreats from the present in quantum relativity. And this was first shown to be the case by Clauser and Friedman in 1972. They showed the instant quantum reaction between 2 entangled quanta when you inspected one of them. And that really, from that point on, I think a lot of people said, let's not think about this anymore because this is just too hard for us, but it's not. And that's where quantum relativity comes in. Here is the top of this blue box is the observable universal event horizon at time now. There was in the past an emission event which took place at the event horizon of time now. And that has, as it were, traveled through space. But at the time of observation, the emission event has fallen back to to 1 i-seconds down into imaginary historic space. So when you detect this quanta of light, the quanta is actually jumping from the historic emitter back to the present through -1 i-second of space and across 1 second of space. And that leads to a formal statement of quantum relativity. We must forget and unlearn that we ever heard the absurd phrase, the speed of light. What a load of nonsense. There's no such thing as the speed of light. But there is an apparent wave velocity. If we imagine waves, then they have a velocity. And what is that apparent wave velocity? Well, it's 1 unit of space divided by -1 i units of history. And the square of the apparent wave velocity, that's c squared, as in E0 equals mc squared, that is inverse unity, or -1. And therefore, both the strong and the weak nuclear forces are gravitational. Because what this is saying is that matter is energy that's lying in a gravitational energy hole. And if you want to see that, you just need to understand the general theory. But then you can just assume that the so-called graviton has a 0 apparent radius. Integrate Einstein's field equations just as they stand. Now that, of course, leads to a bit of a problem in that integration, because if the radius of the graviton, of the effective graviton, is 0, then you do reach infinity, of course. We can show this concept with what I'll call the QR cosmological energy balance model. I've tried to do this for electrons and other things, but my greatest success is with the proton, which is also basically the neutron, but I can only use the proton because that's actually detectable. This disk at the top is a 2-dimensional presentation of the 3-dimensional static or standing event horizon of time now. And the vertical dimension there is a dummy variable. That's the gravitational space scale compression. So to find that curve, you'd need to use Einstein's general theory in 2 dimensions, because to do it in 3 dimensions would be beyond my mind. I couldn't show 3 dimensions on a 2-dimensional, 4 dimensions on a 3-dimensional sheet of paper anyway. So I stick to this simple diagram. This is the graviton down here. It's actually sitting beneath the event horizon of time 0. And this is showing the event horizon of time now. And the reason this is helpful is because it explains to us what matter is. This is a proton, just the standard model elements of, from quantum physics of what a proton is. And that is sitting in a gravitational energy hole. And so Einstein said E0 equals mc squared. Well, c squared has become 1i2 or -1. And so the free space energy is equal to minus the energy tied up in the mass that's in the gravitational energy hole. And so why is this diagram is attractive? Because it explains that the strong nuclear force is actually gravity. And the weak nuclear force is also gravity. Even electrochemical binding energy is gravity, but we can't go into that here for time. So this is 2-dimensional. So that's our proton consists of quantized energetic particles that achieve cavity resonance within a gravitational energy hole. And the strong nuclear force is shown by this diagram to be gravity. It's just at extraordinarily tiny space scales. And this diagram explains the proton charge phase radius, or charge radius of the proton to gamma wavelength discrepancy, because the proton charge phase seems to be 250 times too small to be a quarter wave dipole emitter of the gamma photon or gamma quantum. And the reason for that is that the proton charge phase sits at 250 times spatial compression within this gravitational energy hole. If you can break this proton and I release this energy up above the event horizon of time now, then it's a lot of energy, as we know. So that's it. That's it in a nutshell. I mean, it's taken best part of 16 years for me to develop this theory, and it's there on my website if you want to study it. But it is the general unified theory of universal gravity. And before you can begin, you need to get your mathematics sorted out with the unified theory. Not your mathematics so much as your number theory. You need to understand what numbers are and get rid of the imaginary and abstract. Because the orthodox mathematician's definition of one, it's an abstract quantity, and then you've got these imaginary quantities on top. And in unified finite theory, you say no, there's nothing abstract about it. Unity is an imaginary unit, and it can rotate, and that rotation is real. I mean, imagine a force. You know, what's the negative? Well, it's a rotational inversion of that force, and so a lot of things in physics start to make a lot more sense as soon as you've ditched this orthodox mathematics and adopted the unified theory of finite natural numbers. So that's it, really. I mean, I'd encourage people who are interested to read about it. You're not going to get your head around this in a very short amount of time. But if you've got an open mind and you're willing, then it would only take a few hours, and it's all on my website. So, you know, I'd just like to leave it there and thank everybody for listening. Thank the organisation for inviting me, and say good day.